Hi, welcome to Barney Tech channel. Here we are going to see Spam Spaj relay, how to see the relay settings, how to do relay configuration. We see this all one by one. First we see the relay settings. I theta is the load current. We will see how to set the value over here. Let me see one example. Let us consider the motor full load current is 230 amps and the CT ratio I am considering 300 bar 5 amps. So I theta equal to 230 divided by 300, which is 0.766. Here we no need to consider the secondary current. So we have to set the value on the relay 0.766 over here. Next we will see T6X. It is a stall time maximum and we will see this briefly. It is the operating time in second for 6 times of I theta. For example, I set T6X equal to 20 second. Now we will see how this production is going to work. When the current reaches I theta into 6 times, that is, we are considering 0.766 as a full load current, that is I theta. When the motor reaches 6 times of current, 4.6 amps, and if it is not reduced before 20 seconds, then it will issue trip command to breaker. P is a weighing factor which is used in thermal calculation. Next we will see the theta A. Theta A is a thermal alarm, theta I is a thermal reset, Kc is a cool time constant. This all used for thermal calculation. Let me see deeply. Let us consider theta I we set 70. That means the reset for thermal is we kept 70 degree. While we starting the motor or during running time, if it is tripped by thermal or other factor during that time, the relay thermal value, if it is reach or above 70 degree, then the relay reset contact will not activate and the relay reset also not able to possible. We have to wait until it reduced below 70 degree. From this graph we can clearly able to see above 70 degree the relay will not allow breaker to close or it will not give close enable if the relay thermal value is above 70. If it is below 70 degree then it will allow to close. This curve is also depend on Kc factor. Now we will go for startup current settings and operating time settings. Let us consider the startup current is 3 amps and the operating time is 5 seconds. During starting of the motor, if the secondary current should not exceed 3 amps, so within 5 seconds it can go very high, but after 5 seconds it should come down to normal current. For this I have shown two examples. First one is get tripped due to the starting current is not reached below 3 amps after 5 seconds also. Second one, it's not get tripped due to the starting current reduced normally within the 5 seconds. Now we will go for next production. The I double greater is for instantaneous overcurrent and T double greater is for its operating time. Next the earth fault current is I naught and the operating time is T naught. Next is for unbalanced production delta I and this for operating time is T delta. Next it is a undercurrent I less than and is operating time T less than. If the motor running below the setting current, then the relay will issue trip command. Summation of T SI is a time based starting inhibit count, the minimum successive time between two starting of this motor. Delta TS and delta T is the countdown rate of starting time, that is if the motor repeatedly start stop continuously, which make the blocking for start for this time. Now we go for the relay configuration. The relay configuration is basically depend on SG or SGF and SGB. We see these three one by one. Before going into the configuration, we will see some pattern. If we clear in this, we can easily able to do configuration on this relay. When we see SGR or SGF, all this will have some value. We have to select the function by pressing step down, and now we see in SGF, here it is 84. This value indicate the relay configuration, and for doing configuration we need to press the program button. Once we press it, it will start to blink, and again we have to press the program. Now it will show 1 and space value. This value may be 0 or 1. If you want to change the value, need to press step like this. Similarly, we have 8 step. This 8 value each stay in 0 or deactivate, and for 1 for activate, and they have the different value. Now we see this 8 switch value. Switch number 1, the value is 1. Switch number 2, value is 2, 3 for 4, 4 for 8, 5 for 16, 6 for 32, 7 for 64, 8 for 128. Each switch have the different value. Now we will see this briefly by having some example. Now I am going to do configuration for these 8 switches. The switch 1 is activated over here, so this value is 1. For switch 2 not activated, so the value is 0. For switch 3 it was activated, the value is 4. Switch 4 activated, the value is 8. Switch 5 not activated, the value is 0. Switch 6 it is activated, the value is 32. Switch 7 it is not activated, the value is 0. Switch 8 it is activated, the value is 128. After this configuration, once we save on the relay will start to add all this value. When we make the summation of all this value, the value is 173. This indicates the relay configuration. We can see another one example. For switch 1, I am not activated, so the value is 0. Switch 2, I am not activated, so the value is 0. Switch 3, I was activated, the value is 4. Switch 4 not activated, the value is 0. Switch 5 activated, the value is 16. Switch 6 activated, the value is 0. Switch 7 it is activated, the value is 24. Switch 8, the value is not activated. When you sum all this value, we get 84. So this number indicates the configuration of the relay. Now we will see in each switch what is the specification behind this, so we can be able to do clearly the relay configuration. First we will see SGB configuration. This is the switch group for configuration of blocking or control signal. This is the explanation of SGB. This is having the blocking and control function. This all blocking mainly is work when the binary input terminal 10 and level is activated. We see one by one. SB1 is for stall information of the relay from speed switch on motor. This function will activate when we keep the value 1 and the binary input is activated. When we configure this relay 1, and the same time when the binary input 10 and level terminal is get activated, then only this function will operate. Second, the SB2, this is a restart for a motor inhibit by external command. This function will activate when we keep the value 1 and the binary input is activated. This input we can get from the field side before clearance of the field in order to avoid the motor to start. SB3, this SB3 when we keep activated, that is when we keep SB3 as a 1, then the phase unbalance is blocked when we get the input signal this terminal 10 and level. Normally this we will use during the starting time of the motor. This blocking signal we will get from the starter unit. When the motor is getting started, then the unbalance is blocked during only at the time of motor starting time. Next, SB4. When SB4 is 1 and the binary input terminal 10 and level is activated, then it will block the earth fault. Same as before. This also will be used when the motor starting time, not to avoid unwanted trip. Next, SB5. When we activate this and when we get that binary input 10 and level, which will give the tripping command to output relay 65 and 64, the terminal on 65 and 64. This is the command get from external trip, normally from maybe the speed switch or limit switch from external of the motor. Next we go for SB6. This is for relay reset. Normally this we will use after the production trip. The relay reset from the remote end or from master trip relay. Next is for SGB7 latching output. For short circuit, earth fault and unbalanced trip, this latching output will activate when we keep SGB7 in as a 1. Only this 3 production will get latching. Samely, when we configure SGB as a 1, the for all production the relay will get latched. That means it relay once it get tripped, we need the external signal to reset the relay. Next we go for SGF. It is a switching group function. Depend on this configuration, the main production which was used in the relay we need to activate or deactivate is depend on the configuration on SGF. Now we go to SGF1. If we keep 0, then the high stage overcurrent is disabled. If we keep 1, then the high stage function will be activated. Next for SGF2, if we keep 0, then the motor inhibit by external command is disabled. This external command is from SGB. This can be blocked by using this SGF2 also. If we keep 1, then it will be activated for function link SGB2 for restart of motor inhibit by external command. Now we see SGF3. When we keep SGF3 and 40, then the earth fault will not block during the starting time. When we keep SGF3 as 1 and SGF4 as 0, then the earth fault will be blocked during the time the current reach 4 times of the full load current. During the starting of the time, if the current reached 4 times of the full load current, then the earth fault will be blocked during that time. Same way, when we keep SGF3 as a 0 and SGF4 as a 1, then the earth fault will be blocked only during the time of the current if it reach 6 times of full load current. Before it is 4 times, now it will go 6 times. Same way for SGF3, if we keep as a 1 and SGF4 also as a 1, then the earth fault will be blocked only during the time the current reaches 8 times of the full load current, very high. These two functions mainly focus for blocking the earth fault during the starting time. Next we go for SGF5. If we keep 0 for SGF5, then the unbalance is disabled. The unbalanced production is disabled. If we keep 1, then it is activated. Next SGF6, if we keep 0, then the relay will not check phase sequence RYB for unbalance. If we keep 1, then the relay will check the unbalanced sequence also. In SGF7, if we keep 0, then the stall production based on thermal stress. That is when the motor get high load or when the during running time, if the motor get stuck, then the tripping will depend on the thermal stress. If we keep 1, then the stall production will based on motor starting setting and motor starting time it will follow. That is IS and TS, it will follow these settings for stall also. If we configure a HGF 8 as a 0, then the undercurrent is disabled. If we keep 1, then the undercurrent will activated. Next we will see HGF or configuration. This is a switching group for configuration for output relay. The output relay which all we are going to configure means the terminal 65 and 66 is a main trip contact, and 74 and 75 is a relay reset enable, and programming signal 68 and 69, and alarm terminal 77 and 78, again one more programming signal 80 and 81. These all 5 output terminal have this programming configuration. In this SGR the group we have two group, SGR1 and SGR2. Now we see one by one. Before that we need to have some clear idea on tripping output on 65 and 66. In this all production is configured directly except earthfall production. Only the earthfall production will be activated during the configuration over here for tripping. Now we will see deeply. When we configure SGR1 as a 1, then the thermal alarm is configured to signal to programming signal to terminal 80 and 81. Next, when we configure SGR1 output 2 as a 1, then the thermal tripping signal is configured for programming signal to. Next, for SGR1 3, when we configure 1, then the stall production is configured to output terminal 80 and 81 slash 4 as a 1. Then the high set overcurrent is configured to programming signal to the terminal 80 and 81. When we configure SGR1 slash 5 as a 1, then the unbalanced current is also linked with the same programming signal 2. When we configure SGR1 slash R as a 1, then the earthfall signal also is configured for programming signal 2 over the terminal 80 and 81. When we configure SGR1 slash 7 as a 1, then the signal for undercurrent linked to programmable signal 2 for terminal 80 and 81. To this programming signal 2 we can take for additional production or additional signal to DCS or any monitoring purpose. And for SGR1 slash 8, it's a for earthfall trip for linking to main production trip on terminal 64 and 65 mentioned before. So if we are not configured over here, even though when we keep the settings and even though the LED will operate, but if you are not configured on here, the relay will not give protection trip for earth fault. So this is very important. Now we will see HGR2. When HGR2 slash 1 we keep 1, then the thermal polarity alarm is configured to production alarm 77 and 78. When we keep SGR R2 slash 2 as a 1, then the motor startup production is configured to alarm. Next, when we configure SGR2 slash 3 as a 1, then the high set overcurrent is programmed to production alarm. Next, for SGR2 slash 4, when we configure as 1, then the thermal trip is linked with the programming signal 1 on terminal 68 and 69. Next, when SGR2/5, when we configure as a 1, then the stall production is linked with programming signal 1 terminal 68 and 69. Next, when SGR2/6, when we configure as a 1, then the unbalanced production is linked with programming signal 1 over the terminal 68 and 69. And when we configure SGR2/7 as a 1, the signal for earth fault is linked with programming signal 1 terminal on 68 and 69. The last one, SGR2/8, when we configure as a 1, then the signal for undercurrent is programmed for signal 1 on terminal 68 and 69. I think this topic will be having somewhat useful to you all. We came to the end of this section. See you on next video. If you like this section, then please share to your friends and colleagues. Take care and bye from Barney Tech channel. Thank you for watching this video.